module we will tell you about the different graphs which are there on the ventilator interface, the most important of which is the flow and the pressure graph. We know whenever a breath is delivered, there is a generation of pressure in the airway, there is delivery of a particular amount of volume, and there is a flow pattern in which this volume is delivered in a particular period of time. Let us look at how it happens in volume control mode. Let's say we put tidal volume as 500 ml, inspiratory time of 2 seconds, which would mean that the ventilator has 2 seconds to deliver 500 ml. As we said, the inspiratory time is always fixed in a control mode. So the ventilator knows that if I deliver at 250 ml per second, I will be able to deliver 500 ml in 2 seconds. By convention, we describe the flow in terms of liters per minute. So at 250 ml per second, this would be around 15,000 ml per minute. So roughly comes to 15 ml per minute. Now the ventilator knows that if it maintains a flow of 15 liters per minute during the inspiratory time, it will be able to deliver a tidal volume of 500 ml in 2 seconds. The volume delivery in a volume control is fixed, the time is fixed, so the ventilator calculates, and what it does is, as soon as the inspiration starts, from zero flow, it goes up to 15 liters per minute and it stays constant for the next 2 seconds so that the volume can be delivered, and then the breath cycles and the breath goes into expiration. By convention, in a flow graph, we put the inspiration above the graph and expiration below the graph. What we can see is that the volume delivery is by a constant flow. This gives to a typical square wave pattern to the breath, and volume control modes are defined by this square wave pattern of flow that they create. This initial rise of pressure from 0 to 15 liters per minute can also be said, this is known as the rise time, and this can be set according to the air hunger of the patient. It's not such an important setting to do. And then the flow remains constant, the flow drops, the breath goes into expiration, and again a new breath starts. If you look at the pressure pattern, what happens is the pressure builds up slowly because the flow is constant and reaches a peak pressure at the end of the inspiration, and then the pressure falls back either to the baseline, which is 0, or most commonly to a value of PEEP which we have set. The pressure drops, remains at the PEEP levels for all throughout the expiratory mode. Again the pressure starts to rise, reaches a peak at the end of inspiration and falls back to expiration. This is the typical pattern of volume versus time and pressure versus time which we see in a volume control mode, and we can contrast this now to a pressure control mode and see what happens to the flow pattern and the pressure pattern in a pressure control mode.